Okay, so for clarity's sake, let's draw the waveform on this white piece of paper so that we can see clearer. So the first waveform that we have observed just now is our Vxy, 0 volt, and this is our Vxy, whereby it is measuring this point with respect to here. So this one is our yellow waveform in the oscilloscope that we saw earlier on. And later on, we actually measure the VA with respect to Y. So I'm going to use a different color to represent VAY. So VAY occurs trailing below Vxy and something like this. So this will be our VAY that we saw in the oscilloscope just now. And I'm exaggerating the delta in this region. As I drew here, the delta is bigger than what we saw in the scope. This exaggeration is just for illustration's sake. So what we are seeing over here at the maximum delta point on the scope just now, we are looking at about 1 volt difference. And during this whole period of time, I will call it A. Sorry, I shouldn't use A. Let's call it period time B. During this period time B, the diode is forward bias, because we also observe that during this period of time that the current waveform, the hum, this is a 0 amp, and this is my I motor that we measured using the current probe just now. This positive current aligns with this time B here. And at this time, I shall call it time C. At this period of time C, our motor records 0 amp. So during this time, whereby it's 0 ampere, the diode is being forward biased. Vx, this point, it is smaller than VA, this point. So during this whole period, the diode is reverse bias.